the 9th of February all day long is covered before. Honors geometry with the smiley face. I'm not sure who added the smiley face, but it's nice. You guys will be able to prove triangle similar by angle, angle, side, and it got crossed out. But it's side, side, side. So anyway, we proved triangles congruent. Okay, talking about congruency. Jump back a chapter in 5 different ways. We had side, angle, side, angle, side, angle, side, 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 angle, angle, side, and hypotenuse leg. The 2 that we didn't have were angle, side, side, because that's a bad word. No, thank you. And then also angle, angle, angle was not one. Now we're going to prove triangles are similar. You could either just do the squiggly for similar, or you can write out the word similar. We can do this in 3 different ways. Okay, so we're going to have 3 different similarity shortcuts, just like we had those 5 congruence shortcuts. Okay, so for these triangles A, B, C, and D, E, F, we could do angle, angle similarity. Okay, so you could do, let's say here, if angle A is congruent to angle D, because they would correspond, and let's say angle B is congruent to angle E, then the triangles would be similar. Now, did I have to pick exactly those 2 sets of angles?
No.
No, I could have really picked
C and F.
I could have picked angle C and F as well. I can pick any 2 pairs of angles. So I could have picked any 2 pairs. Okay? It might be helpful to write that in somewhere. Now, you could have picked any 2 pairs there. Okay, that way when you're looking back, you're not like, why did it have to be those 2? Okay, it really could have been any 2 pairs. So for side, 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 here, are we going to say that the sides have to be congruent? Are we going to say that corresponding sides have to be congruent for this to work? No, we're going to say that corresponding sides have to have equal ratios. So let's say the ratio of A to B is over DE is equal to the ratio of segment AC over segment DF is equal to the ratio of segment BC over the ratio of segment EF. Then the triangles are similar. So for this little note we can write is that all the ratios have to be equal. So even if you don't know anything about the angles, if the corresponding sides have equal ratios, all 3 sets, then the triangles are similar by side, 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 similarity. Now one thing I want to note real quick before I go to the last one is as we're saying this, notice this is angle, angle, similarity. Side, 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 similarity. The last one's going to be side, angle, side, similarity. Does anyone have an idea of why we might tag on the word similarity and the symbol similarity on these 3 versus compared to before?
They're not the same.
Because they're not the same, right? We don't want to confuse side, side, side similarity with side, side, side congruence. So instead of me having you guys write congruence after all 5 of these, which was what a lot of people end up doing, I just said, hey, let's think of those as the normal ones, and then think of these as just the similar ones or the ones that are different. Does that make sense? No. They're not a race. Anyway, and it's not discriminatory. So side angle side similarity. So let's say here, segment. No, side angle side is not a bad word. So segment AB over segment DE is equal to the ratio of segment AC over segment DF, and let's say angle A is congruent to angle D. I was blanking there for a moment. So for this one, notice where's the angle located in side angle side?
The last one.
Between the 2 sides. Okay? As far as the SAS is between the 2 sides. And when we look at the sides here, AB and AC, angle A is between them. Side DE and side DF, angle D is between them, okay? So for this one, it has to be 2 side ratios are equal. And I'm going to put that and in all caps because it's really important. And included angles congruent. And the included angles are congruent. So they had to be the included angles. You guys remember talking about the included angles before? There's an angle that has to be between them, okay? If something's included, it's going to be in the mix of things. It's going to be in the middle of things rather than way off to the distance and on the outskirts of things, okay? Yes, Aaron.
Is the bottom A or AB is congruent that last number?
This one?
Vertical flare, yeah.
D.
Okay,
D as in doggo.
I can't read your handwriting.
That's fair. All right.
I can read it kind of.
No, when we prove similarities, the angles have to be what? Congruent. And the corresponding side lengths must be proportional. AKA the ratios are equal. Because proportion is equal ratios. Now, what would happen, though, if these side lengths were congruent? Instead of just proportional. What if they were congruent? What would we have? If the corresponding angles were congruent and the corresponding side lengths were not just proportional, but the corresponding side lengths were also congruent, what would we have? Congruent triangles, right? We had that last chapter. All right, moving on.
This song is a bomb.
It is. So, yeah, I see a lot of people bobbing their heads on it now. It's kind of funny.
Wait, if two triangles have the same side length,
Yep.
does that mean the angles are the same, means it's congruent?
Yep. So if all sets of side lengths are the same, they're congruent.
So the congruent is similar to nothing else.
Correct. All right. So here, we're trying to say on these four examples, can we prove the triangles to be similar by either angle, side, or side, angle, side? Okay. Well, here, do we know any of the side lengths? Okay. So what would probably be our method that we can try?
Angle.
Probably angle, okay? Where we have two sets of angles, congruent to two sets of angles. What do we know right now, I should say? Okay?
We could know three.
We know 57 and 57 are congruent, but we could know the other one. How do we find another angle here?
Plus, and then subtract.
Okay, add two angles up to... Add two angles and subtract that from the 180, okay? So, let's find angle K. So, 57 plus 48 ends up being 105. So, what does angle K end up being? 75 degrees. Is that congruent to angle P?
Yes.
Okay, I'm going to put 2 marks there. So do we even need to worry about angles J and K?
No.
No, because, and this is why it's only angle rather than angle. If you know two sets of angles, do you automatically know the third set of angles? Yeah, by the third angles theorem. So now we could say that triangle blank is similar to triangle blank by angle similarity. Can somebody help me fill in those blanks I left? Okay, so triangle LKJ. And how would we do the other one then? MPQ. Very good. So if you call the first one LKJ, the second one has to be called MPQ. Yep,
I'm not going to read that.
that's fair.
On the homework,
Straight lines.
hypothetically speaking, if we don't have that similarity, will we get a point on?
Yes.
Well, we get half the point off.
Yes. Depends. I don't know. Yes.
Should we just write?
You will not get the full credit.
Sim.
No. Just do the similarity statement.
I bet you
Get
can
the
prove it.
squiggly line.
Well, this will be good practice for you.
It will be good practice.
Okay? Your mom will be proud.
I bet if we can prove it's congruent on the similarity.
I don't think there'll be one like that. Let's go to the top right. All right, we have two triangles here. Do you guys see the two triangles?
Square.
Okay. Do we know anything about these triangles right now?
We know that the two sides are
The vertical angle.
Yeah.
Okay, we know the two sides are what? Parallel. Okay. And then we know we have some vertical angles right here, right? What do you know about those vertical angles? That those angles are congruent, equal measure. Okay. And we know we have these parallel lines. Well, how can that help us with those parallel lines?
Because the angles are congruent.
Boom, alternate interior angles, angle W and angle R are alternate interior angles. Two parallel lines cut by the transversal. Could we have also done the same thing with angle X and T? Sure. Do we need all three though? No, because once you know two, you automatically know the third. So now can we say these triangles are similar already? Boom. Okay, who wants to give me the similarity statement this time?
RSX.
Okay, triangle RSX. If Dominic starts that one off, can somebody finish this one off? Somebody else finish it off. Liam.
WST.
Okay, WST. I'll agree with that. By what theorem did we use? Angle similarity.
Angle squiggle.
Yes.
Angle, angle, swiggle.
Wait.
Howdy.
It's a boy. Angle, angle, swiggle.
What's up?
If we had the same exact question on this exact question on the but for a reason why we put two F, but then it's a line.
Stop asking so many questions.
M and a line through it?
Yes.
I don't understand.
If you take
Well,
M,
I didn't
you put
do
a
my
line
best
through
till
it,
the
put a squiggly line. But it still works.
Oh, you're saying it's kind of like that. I gotcha. Okay. Anyway, let's look at the bottom left-hand side. Woo, these triangles are kind of weird, aren't they?
God, there's like 4.
Okay, there's a lot of stuff going on here. Okay, let me first of all say, 8. Okay, the length of 8 there is the length of M to P. M to P is the 8. Okay, does that help clarify some things? Okay, Sarah, what are you seeing?
So would MQ be 12?
M to Q would be in fact 12. Okay, so we know their side lengths. We know these angles, are marked congruent there.
Yeah.
And then we could try and do side angle side with 2 sides in the included angle. What would be the ratios we have to set up? Because we have to prove that the ratios are equal. Okay, Max, you got these? Yep, we have to set up 2 ratios and a proportion and see if it's true. Okay, that could work. 4 over 8 is equal
By 2.
to 6 over 12. That could be one that you could do. So what we did there with our numbers was we did 4, small triangle, over 8, small triangle, is equal to 6, small triangle, and corresponds with 4, over 12, big triangle, and corresponds with 8. Any questions on the setup here so far? Now, if these ratios are in fact equal, then the triangles are similar by side, angle, side. Now, 4 over 8 and 6 over 12, a few different ways we can do this. You can simplify the fractions and see if you get the same thing. You can divide 4 over 8, 6 over 12, like legit in like a calculator, get a decimal, see if they're the same thing. You can cross multiply and see if you get the same thing on both sides. Any of those methods will work to tell you whether or not the ratios are equal. Okay, let's try them. So 4 over 8, what do those both simplify to? 1/2. Okay, if you were to cross multiply, 4 times 12 is 48, and 6 times 8 is 48. Okay, and if you were to type in a calculator, 4 divided by 8 would come out as 0.5, and 6 divided by 12 would come out as 0.5. So no matter what, okay, you can see these ratios are equal. So now we know that the triangle blank, blank, blank is similar to triangle blank, blank, blank. And this time, like Kaya said earlier, it is side, angle, side, similarity. Okay. Does anyone want to try giving me the similarity statement this time? Okay. Jake, you want to try it?
Triangle NMA.
Okay.
RQM.
I'm going to disagree. So if we start out with triangle NMP, then we have to do triangle R, but then where would we go? M to the congruent angle. Because M corresponds with M for the triangles. Q.
It's like a mirror. But it's weird.
Yeah, it's kind of like a weird, it's like a funhouse mirror.
Like the ones in the big size, half that big.
Yes. Like when a child steals a phone.
Yes.
All right, questions on this?
Yes, actually, why do you think that, like, your T, like this giant T, this is cut off, and now it's in there. No, but over the entire thing, the thing that's separated.
Oh, this? It doesn't go that far?
Yes.
Yeah, I don't know.
Okay.
All right, so
Why not?
let's continue on. This bottom right-hand one. What do we know?
That. Wait, this is scaly. No,
No, they're isosceles.
Okay, they're isosceles triangles.
they're not, there's no similarity between them. Like, there's nothing that's the same. Cause the two dash sides are on one side, and the one is.
Okay, so this is 61 and this is 61,
Yes.
and these two angles are congruent.
Do we know the third angle?
Those ones would be 58.
Okay, this one would be 58, right? And so are these triangles going to be similar?
No.
Okay, so they're not going to be similar because the angles are not the same. We can already prove that. Now, here's also one thing I want to point out to you, though. Would the side lengths have been proportional?
No.
Let's think about it this way. What could we call this side length?
A.
Okay, cool. Let's call it A. What would we then call this side length?
Billy.
Okay, excuse me. The measure of this side length, what could we call it? Like how long?
2.
Okay, let's just say it's A. Okay, let's just say the side length is A. Would that be this side length? Would that side length also be A?
Yes.
Okay. What do you want to call this side length over here?
B.
B, okay. What do you want to call this side length then? B as well. So the ratio would be like A over B is equal to A over B. So are they proportional?
Yeah.
On these two they are, but the included angles weren't congruent. So side angle side wouldn't work anyway, and you didn't know the third sides. So no matter what, you either don't have enough information this way, but when you start doing the angles, you just straight up know that they are not similar, and your reasoning could be as simple as 57 is not equal to 58. You could say the angles aren't congruent. You could say 61 is not equal to 61.5, which those two angles would be.
Forgot to put down the upside down 7.
Can I put a slash through this?
I've never seen it, but probably. We do that with all of our other ones, so I would imagine that that's one. I've never seen it, but I would imagine you could. Yeah, sure. I'll count it. Any other question on this? All right. So, we're asking two different questions. Is triangle KML similar to triangle QSR? And I want to know, okay, then is triangle NPO similar to triangle QSR? So notice, I want us to do this separately, okay? So let's even just cover up that for a moment. Let's pretend that doesn't exist for a moment, okay? I'll cross that out differently so it makes it easier for me to erase later. Okay? So let's just pretend it doesn't exist for a half moment. Is triangle KML similar to triangle QSR?
Yes.
So this time, let's look at the ratio of the corresponding sides, and it just kind of organizes it for us if we want to do that. So we can do the short sides together. So you could do like 6 and 10. Now, if we're doing 6 on the top, what do we have to put on the bottom then? 10. For the middle sides, which one do I have to put on the top, the 15 or the 25?
15.
15, I have to match it to what I did on the first one. And the last one would then be 18 over 30. Now, 6 over 10, if we want to reduce this, we could reduce, or we could do decimals, whatever you want. 6 over 10 reduces to what? 3 over 5, okay? I was making Sierra and Ireland do reducing fractions yesterday during conditioning.
Yeah, it's so hard to reduce up to over 10.
15 over 25. 3 over 5. Yes, fractions divided by 10 are nice. And then 18 over 30? 3 over 5. So, are the triangles similar?
Yes.
Yeah, so you can say triangle KML is similar to triangle QSR by what this time?
Side.
Side. Similarity. Don't forget the similarity thing. If you were to forget similarity on that, you'd probably lose a point or a half point at least on a test. Hint.
Yes.
Similarity is.
We're just learning it for absolutely no reason.
How do you
I mean, some students feel that way.
Is factoring on the test?
similarly help you with the
So like I answered earlier, carpentry could be a big application of it. Or architectural, architecture, engineering, drawing, and a lot of artwork it could. Making sure that you make something proportionally bigger. Make sure the triangles are similar. Make sure the angles stay the same. Not to actual size, or not to scale, or similar like that, or not actual size or scaled down, that kind of stuff. Yep.
Enlarged to show texture.
Yes, enlarged or so texture, like it's enlarged proportionally usually. Yeah.
It's a little off track, but
Okay.
Have you had any recent job openings?
Like, have I looked at any?
Yes.
No.
Have you seen any?
He's lying.
No.
That's what Mr. Wallace said.
Okay.
He's building up trust just to tear us down.
I mean, my only goal is to make you guys cry,
Just
so
like Seth. He's getting his revenge on Seth.
that might be the only reason to be worth it. All right. Anyway, I want you guys to do the second set, NPO and QSR. Are we thinking these are similar or no?
No.
Yeah, we're thinking they're not. If we compare these ratios, okay, between triangle NPO and triangle QSR, we're gonna notice we get like 3 over 10, 5 over 25, and then 7 over 30. But 3 over 10 doesn't reduce. That's 0.3. 5 over 25, reduces to 1 over 5, and that's 0.2. Are those the same thing? 0.2 and 0.3? No, so we don't have to get to the third one and know that 7 over 30 is not the same thing at all either. To know that, hey, these are not similar. And Gage said, hey, is that enough? Or something similar to that? And I said, yeah, that's a good enough explanation.
We don't need to
Nope, you don't need to do a similar statement when they're not similar. Correct. Yep.
Can I do 7 doesn't go to 30?
It does.
7 doesn't go into 30 isn't explaining enough here. Although that's true.
30 is not equal.
If you say 7 over 30 is not equal to 1 over 5, or not equal to 5 over 25, or not equal to 3 over 10, that'd be good enough. Does that make sense? Okay, because then you're actually comparing two things still. You're saying, hey, the comparison fails. Any other question on this? I don't know. Great question.
Probably the physics test.
Maybe he's taking care of Will. Whoever that is. Honestly, I still don't know who Will is. Okay. Let's skip letter A.
Probably broke his eye.
What's number A?
Number A.
He's only broken.
Obviously.
He probably.
Let's look at letter B. I want you guys to try letter B. When you have it or have questions, raise your hand. It's a bad problem because you do it one way and you get them to be not similar. You do it another way, you get them to be similar. Let's look at the one that's not similar first. So, if we compare the ratios and say 4 over 5 for small triangle to small triangle, and then compare that to 10 over 10, is that the same at all?
No.
No, they're not the same. So you can already start saying, oh, they're not similar. But wait. We know that this set of angles are congruent. And do they share angle A?
Yes.
So angle A is congruent to itself. So by angle, should they be similar? Yeah, so this is a bad problem. This triangle couldn't exist.
So it's similar but not.
Yeah, this actually doesn't exist. Like legit.
But literally, it does.
Yeah, literally it doesn't though.
Wait.
So this is a bad problem and needs to be thrown out.
Wait, no,
Whatever you make, this is do it.
Yeah.
I was still erasing the 10-10 because you said it was right, because I put 5 over 10.
We should call him Mr. Fossil because he's so old.
But did you do 4 over 10, Aiden? And if you did 4 over 10,
No,
is
I did 4 over 6.
oh, so it should be 4 over 10, not 4 over 6. Yeah, you should call me Mr. Fossil because I'm old. Although you guys do keep me young. Yeah, being here, you guys keep me young. They're pretty cool. Little scary though. So you just have to know you just need to know how to tame them, know how to treat them.
Velociraptors open doors.
No,
Did you have a
no. Even when they were alive, they couldn't.
Were doors invented back then?
No, that's why they couldn't open them.
Was it scary when Moses broke the 10 Commandments?
It was weird when he came down from the mountain. Sorry, say this one more time.
I'm confused.
Referencing the 10 Commandments.
No, I didn't hear what you said.
Was it scary when your oldest brother died?
Oh, I think I know what you get.
You lost me on that one.
How was it building
10
the Great
Commandments
Wall?
Mhm.
during, like, the firstborn died?
Oh, before that, yeah, the Passover to Egypt. Yes. In the Bible, there is part of the Bible that talks about in the book of Exodus where, as Israel was leaving Egypt, there was a Passover where there was a plague where the firstborn died. In that story.
How did you survive the meteor?
So,
I just thought that
did I survive the what?
How did you survive the meteor?
The meteor?
Yeah.
I thought you said the media. I'm like it didn't exist. But the meteor, dodge, duck, dip, dive, and dodge. Come on. All right. Yeah. So don't do numbers 4, 5, or 9. And on number 7, it should be the measurement of segment QR you're looking for, not the measurement of segment AC.